Guys, I'm gonna go over the appendicular skeleton. So the appendicular skeleton consists of the pectoral and pelvic girdles, which hold your upper and lower limbs in place. Okay. So starting off with the pectoral girdle, the pectoral girdle consists of the clavicle and the scapula, but the clavicle is the only portion of the upper appendicular skeleton that articulates with the axial skeleton. So the scapula does not articulate with the axial skeleton. The clavicle, though, articulates with the manubrium of the sternum. Remember, here are the clavicular notches at what's called the sternoclavicular joint. And then the scapula articulates with the clavicle. All right, so getting into the clavicle has the acromial end, which articulates with the acromion of the scapula, and that's going to be more laterally. And then medially, it has that sternal end. So the sternal end is more pyramidal in shape, which you can see here. And the acromial end is broader, it's more flattened in shape. So that's how you can tell the difference. And the way that I always know if I'm looking at the anterior or posterior clavicle is I like to think that this kind of depression here, it's always going to be like pointing away from me if it's pointing anteriorly. That's pretty much all you need to know about the clavicle. And now getting into the articulations. Remember the sternal end, the more pyramidal end, articulates with the clavicular notches of the manubrium of the sternum at the sternoclavicular joint. And then moving laterally, that acromial end, the more flattened portion, is going to be articulating laterally with the acromion of the scapula. So you can see that all right here, and notice that this looks like it's kind of pointing away because we're looking at it posteriorly, but yeah. All right, so now moving on to the scapula, the second part of the pectoral girdle. So from this posterior view, we can see this spine, which is just a ridge of bone that divides it into the supraspinous and the infraspinous fossa. And so if you feel your own scapular spine and you trace it laterally, you'll come to this projection of bone called the acromion. And that, if you can feel it, it's the bony tip of your shoulder here. And so the more anterior projection from the acromion is the coracoid process, which they say looks like a crow's beak. And you can look at the borders and the angles, but I'm not really worried about that. What is important is from this lateral view of the scapula, you can see this glenoid cavity here. That's where the head of the humerus articulates with the scapula, and that's a ball and socket joint. So you can do a wide range of movements there. Sorry about my dog. So now looking at the anterior scapula, there's no spine, it's much smoother, and you can see this subscapular fossa, which will be covered by the subscapularis rotator cuff muscle. So now looking at the scapula's articulation, so laterally, the acromion of the scapula articulates with the acromial end of the clavicle here, and then the glenoid cavity articulates with the head of the humerus here. You can see that. So now moving on to the upper limb, which is composed of the humerus, the radius, the ulna, the carpals, metacarpals, and phalanges. Starting off with the humerus. So here's your humerus, your arm, at least your anatomical arm, just this portion up here. So you can see that the head is going to be more medial, and that's going to articulate with the, remember, the glenoid cavity of the scapula. So that's the head of the humerus. And so this anatomical neck, it's just going pretty much around the circumference of that head. And this anatomical neck is actually remnants of the former epiphyseal plate that was there when this bone was being formed. So if we look on the lateral projection, at least lateral to the head, is this greater tubercle here. And then more medial, it's a smaller, lesser tubercle down there. And then right in between the two tubercles is the intertubercular sulcus. Kind of highlighted that in blue over here. And then just posterior to both of the tubercles and the head is the surgical neck here. And now moving inferiorly towards the distal portion of the humerus, we come across the epicondyles and then the condyles here. So these epicondyles, they are just bony side projections. So you have a medial one on the pinky side and then a lateral epicondyle on the thumb side. So if you can feel these two bony projections on the sides of your elbow, you're feeling the medial and lateral epicondyles of your humerus. And then now we see the condyles down here. So on the radial side or the lateral side is the capitulum of the condyle. And then moving medially, we get to the trochlea of the condyle. So the head of the radius is going to articulate with the capitulum. So you put a cap on your head, capitulum on the head of the radius. And then the trochlear notch of the ulna is going to articulate with the trochlea of the humerus here. And now moving posteriorly, we can see the trochlea continues posteriorly, but we see this fossa here, this olecranon fossa. And the olecranon fossa is going to accommodate the olecranon, which is the bony tip of your elbow, which is part of the ulna when your forearm is extended. So the olecranon, you can literally feel it kind of moving into that olecranon fossa. This pretty much just summarizes what I just said, but here you can see the head of the radius articulated with the capitulum, and the trochlear notch of the ulna fits perfectly into the trochlea there. And the radial and coronoid fossas here, they're just going to accommodate the head of the radius and the coronoid process of the ulna, which is just this portion right here, when your forearm is flexed. But so when your forearm is extended, you can see the olecranon of the ulna fits right into that olecranon fossa of the humerus there. I tried to show you that the head of the radius and that the trochlear notch of the ulna are in the radial fossa and the coronoid fossa over here, but it's definitely hard to see. But you can see that when your forearm is flexed, the olecranon fossa is unoccupied. All right, so now moving on to the radius and the ulna. So they are the bones of the forearm. The radius is lateral. So if something's rad, you give it a thumbs up, the rad radius. And then the ulna is on the pinky side. So the ulna is more medial. And so here's the head of the radius, the trochlear notch of the ulna. The olecranon is the more posterior portion of the ulna. And then right here, this like inferior lip of the trochlear notch is called the coronoid process, which remember goes right into the coronoid fossa when your forearm is flexed. All right, and so moving towards the distal end, we can see we don't have epicondyles, but we have what are called styloid processes. And so if you can feel these bony projections just before you reach your carpal bones, you're feeling the styloid processes. Obviously, if it's medial, it's that of the ulna, and if it's lateral, that of the radius. Okay, let's see. So here's the olecranon, trochlear notch. And then one more thing to mention is that not only do both the radius and the ulna articulate with the humerus, but they also articulate with each other. So proximally, the radius is thinner and the ulna is thicker. So the thicker proximal ulna is going to have what's called a radial notch, and that's just going to accommodate the head of the radius and form what's called the proximal radial ulnar joint. And then moving distally, we can see that the radius now is thicker and the ulna is thinner. So the thicker radius is going to have an ulnar notch, and that's where we'll have the distal radial ulnar joint. And so the proximal radial ulnar joint is a pivot joint, and that allows your your radius to cross over your ulna during pronation. And I just circled the joints again. All right, so now moving on to the distal articulations, our wrist joint. Only the radius is forming the wrist joint. The ulna does not articulate with any carpal bones. Your radius is going to articulate with the scaphoid and the lunate carpal bones, and it's going to form a condyloid joint. So you're going to have flexion, extension, and then also ulnar deviation and radial deviations of the wrist due to the articulation of the distal radius with the scaphoid and lunate bones. And make sure you know that the ulna does not articulate with any carpal bones. Now moving on to those carpals, metacarpals, and phalanges. So your carpals, you have 8 carpal bones, and those are just forming your wrist. So you have a proximal row and a distal row. You only need to know 3. So your scaphoid and scaphoid lunate are in the proximal row, and those are just articulating with your radius to form the radiocarpal joint, the wrist joint. And then the other carpal bone that you need to know is the trapezium here. So the trapezium is going to articulate with your first metacarpal, and it's just going to form a saddle joint. So it allows opposition of the thumb, flexion, extension, adduction, abduction, and circumduction of the thumb. So that's the trapezium there. So here are your 5 metacarpal bones. And so your metacarpals and phalanges are numbered 1, 2, 3, 4, 5. So the pinky is the 5th finger, and the thumb or the pollex is the 1st. And remember, you point with your pollex. So you have the 5 metacarpals, and so proximally the metacarpals will articulate with the distal carpal bones, and then distally the metacarpals will attach with the proximal phalanx. And so you have 3 phalanges in fingers 2, 3, 4, and 5, and then you only have 2 phalanges in the pollex. All right, moving on now to the pelvic girdle. The pelvic girdle actually only consists of your os coxae, your hip bones, whereas the pelvis consists of the sacrum and the os coxae. So here's just the pelvic girdle, and then here's the pelvis over here. And so the head of the femur right here is going to articulate with what's called the acetabulum on the lateral portion of the os coxae. So first, this is just an overview of the parts of the os coxae. So you have the ilium, the ischium, and the pubis. And then here are the posterior views of those. And before we go on, I just want to remind you of this sacroiliac joint. So here's the ilium, here's the sacrum. And as you can see, each os coxae articulates posteriorly, right? Because here's anteriorly is your pubis and your ischium. So posteriorly, the os coxae, specifically the ilium, articulates with your sacrum at the sacroiliac joint. Okay, so now moving on to the os coxae. So I've tried to make it very clear which portions are which on the os coxae. So here's the ilium. As you can see, it's the largest of the 3 bones. And so your ilium is going to be forming most of the superior os coxae. And it's also going to be forming the largest portion of the acetabulum here. Remember, that's where the head of the femur articulates. You don't need to know too much detail, but what you do need to know is that here, your iliac crest, here's the iliac crest. If you feel your hip bone, it's the superior most portion of the os coxae. And the greater sciatic notch, it's on the more medial side. Here's your greater sciatic notch of your ilium, and then that would be right here. That's just where your sciatic nerve is going to be traveling all the way down to your lower limb. And then one more thing about the ilium, it's the iliac crest. Is the anterior superior iliac spine. So you can see that right here on this image, the anterior superior iliac spine, anterior superior iliac spine. And what's important about that is that in females, it's about the level of the ovaries. All right, so now moving on to the ischium. So the ischium is going to be forming the posterior lateral border. Oh, I'm sorry. The ischium forms most of the posterior portion, also the inferior portion, which you can see that clearly, I think, here. Let's see. So you can see it forms the posterior 2/5 of the acetabulum, right? And what we really talk about is the ischial tuberosity. So the ischial tuberosity, that's going to be this portion right here. It's the posterior inferior portion of the ischium, and that's the portion that you sit on. So if you're sitting straight up in a chair, you can actually honestly feel it. Yeah, I'm touching my ischial tuberosity right now. It's just the part that you sit on. And then finally, we get to our pubis. So the pubis is the most anterior portion. As you can see, it does comprise part of the acetabulum, but the smallest part of it there. But what's notable about the pubis is that the two pubices, or each pubis of each os coxae, articulates anteriorly. There's a pad of fiber cartilage here, and so you know it's an amphiarthrosis. So it's going to allow a little bit of movement. When a woman gets pregnant, your pelvis will have to expand to make room for the baby, and then eventually allow the baby to get through that birth canal too. So here you can see that the acetabulum is going to be on the lateral side, right? Because the head of the femur has to articulate with the lateral side of the os coxae. The more medial side is where you're going to find the greater sciatic notch. Yeah, I think if you just spend a little bit of time trying to get to know the os coxae, you can do it, even though it's a really weird bone. All right, so now moving on to the lower limb, which consists of the femur, the patella, the tibia, the fibula, the tarsals, metatarsals, and phalanges. All right, so starting off with the femur, here is the head of the femur. Remember, that's on the more medial portion of the femur, but it's going to articulate with that lateral acetabulum of the os coxae. And then just distal to the head, you can see this neck here, and the neck is right between the head and what's called the greater trochanter. So remember, the humerus had with a greater tubercle. Well, the femur has this greater trochanter. And someone said you wear tube tops on your upper portion. So remember that the tubercle is on the humerus, and the trochanter, you're just going to have to remember, lateral portion of the femur. And then the lesser trochanter is more on the posterior-medial surface. So you can see that there. And then moving down the shaft, moving to the distal portion, we have, just like on the humerus, epicondyles. So if you can feel the bones on each side of your knee, you're feeling your medial and your lateral epicondyles of your femur. Okay, and so now, unlike the one condyle on the distal humerus, the femur, the distal portion of the femur, has two condyles. So it has a lateral condyle and a medial condyle. So here's the medial condyle, right? Because the head is medial, so you can tell that's the medial condyle. And then the lateral condyle here. And then, of course, the epicondyles are above those respective condyles. But on the anterior portion of the condyles, we have the smooth patellar surface, because we're going to get the articulation of the patella with the femur at that patellar surface. So let's get into these articulations. So proximally, we already mentioned that the head of the femur articulates with that lateral acetabulum of the os coxae here, and that's going to be forming another ball and socket joint, your hip joint. But then moving distally, and this is the posterior view, here is the anterior view, we can see that the medial condyles of the femur are going to articulate with the medial condyles of your tibia. And then the lateral condyle of the femur articulates with the lateral condyle of the fibula. So it's really worth mentioning that the fibula does not articulate at all with the femur. Only the tibia articulates with the femur, which is different because for the humerus, both the radius and the ulna articulated, but nope, not the case here, only the tibia. So only the tibia touches the femur, articulates with the femur. And then one more thing here, remember the anterior patellar surface, because the patella articulates with the femur there at the patellofemoral joint. And I forgot to mention that the articulation of the tibia with the femur is your knee joint, aka the tibiofemoral joint. And I just really wanted you to be able to see that the patella articulates right at that patellar surface only with the femur, not with the tibia. So now moving on to your patella, your teeny tiny little kneecap. It's located in the tendon of your quadriceps femoris muscle, which is one of your 4 quadriceps muscles. And I think it's really clear here, which is nice. This is the patellar ligament. Don't worry too much about that. And so here's the articular surface of the patella, which just goes right onto the patellar surface of the femur. All right, so now we get into our leg bones. So the tibia and the fibula, the tibia and the fibula. So the tibia is thick, the thick tibia. The tibia is medial, and then I always say tibias touch. So like if you go like this, tibias are touching, and that's what I mean by that. So that's how you can remember that the tibia is more medial. And then you can see the fibula is way thinner than this thick tibia, and it's lateral. So the tibia is the only weight-bearing bone, right? I said only the tibia articulates with the femur via its medial and lateral epicondyles. And so the fibula does not articulate at all with the femur. And then moving distally down here, we can see that both the tibia and the fibula articulate with the talus, but the tibia definitely has a much larger portion in the what's called the talocrural joint, because your leg region is your crural region, and then the talo obviously refers to the talus. But you have on each side of the distal portion of your leg what are called malleoli or malleoluses. So if you feel these bony bumps, I don't know if I should show my foot, but here is my medial malleolus. And then on the other side, obviously, is the lateral malleolus. So you can feel those. All right. And so, yeah, that's what you need to know. But I just want to mention that the fibula and the tibia do articulate proximally and distally with each other. So you can see the articular facet on the head of the fibula articulates with the fibular articular facet on the tibia. So here's your proximal tibiofibular joint. And then down here, the fibula articulates with what's called the fibular notch of the tibia at the distal tibiofibular joint. So just like the radius and the ulna articulate both proximally and distally, the tibia and the fibula articulate with each other both proximally and distally. Oops, sorry. I just want to mention again that remember the talocrural joint. So your tibia articulates with the talus, your first tarsal bone, and so does your fibula. But your fibula articulates with the talus just laterally. It's pretty much just there for support. Okay, so now your tarsals, metatarsals, and phalanges. So here's your medial tibia and the lateral fibula. You only need to know your tarsal, oh my gosh, I wrote that wrong. This is a tarsal bone, but this is supposed to say talus. So you only need to know your talus, tarsal bone, and your calcaneus. So here's your calcaneus. It's pretty big. It forms your heel. So if you can feel your heel, you can feel your calcaneus. And then obviously your tarsal is the It forms the superior most proximal region of your foot. And like I said, like 5 times, I think it articulates with both the fibula and the tibia. Oh my gosh, the fibula and the tibia at the talocrural joint. And so then moving on from your tarsals to the metatarsals, just like in the hand, just like how you have 5 carpals, you have 5, oh my gosh, just like you have 5 metacarpals, I'm so sorry, you have 5 metatarsals, which are the bridges between your tarsal bones and your phalanges. And just as in the hand, you digits 2 through 5 have 3 phalanges each, whereas the hallux, aka the big toe, sorry, I spelled that wrong there, only has 2 phalanges. And so, yeah, that's the appendicular skeleton. I hope that was helpful. Oh my gosh, I can never figure out how to stop this.